Hey, so today we're going to be looking at changes in position over time and the way more common name that we use for that. Here in physics, we're all about kind of describing what physical things are doing and how they're changing. So let's say right here, I'm standing here. Ooh, that was way too big. We're going to go down here. So let's say I'm standing right here. Okay. And just to make sure that's me. There we go. Now we know that that's me. So let's say I'm standing 5 meters away from a wall. And from that point, I then walk, pretend that's a straight line. I walk another 25 meters away. Well, so then I'm 25 meters away from the wall. And perhaps I should even put that right here. There we go. Wall right there. And I'm moving. And let's say that it's going to take me, let's say, if I'm moseying around, we're going to say it takes 15 seconds to do that. All right. So now I've changed my position. I was 5 meters away from the wall. I'm now 25 meters away from the wall. That means a change occurred. And this is kind of common sense, but in physics, we break things down into very, very, very simple terms. So I changed position by a certain amount, and we can figure that out. And so position we use is x. And to get us kind of in this physics mindset, typically if we're describing a change in something, that means it started or had an initial value. So we typically use a subscript I to represent that. If x is distance or position, I is the initial position. And if it's changing, that means we also have a final position, which we'll use an F to signify that. So we said our starting position was 5 meters, and we ended 25 meters away from the wall. And keep in mind, we're basing both of these values based on a point of reference, a frame of reference. In this case, our point of reference is the wall. Keep in mind, this is one directional movement. Essentially, at one side of the line, we have the wall, and we only have this one direction of movement, either away from the wall or towards the wall. So in this case, I had my change, I had a starting position, I had an ending position. We're more concerned with the change in position. And for those of you that took chem, that Greek letter right there, not a triangle, not this time. The Greek letter delta simply stands for change in. So in this case, we're looking at the change in position, the change in x. So whenever we're looking for the change in anything, we're going to take the final of whatever value we're looking at, and we're going to subtract the initial. All right, so final minus initial. So in this case, we have 25 meters minus 5 meters. 25 minus 5, we should get 20 meters. Change of position's a good thing to know in physics. It lets us know where one thing began and where it ended. That doesn't tell us, though, that is good data, but it's not very useful data. But on its own, that's not going to tell us a lot. At least not until we get to electromagnetism. Yay, foreshadowing. What would be really good to know is the rate of change of position. How much did our position change over time? So in this case, that's why I kind of mentioned that here. So we can have change in position over time. So in this case, we're working with meters. Our change in position was meters. Our time was seconds. Meters per second That sounds familiar. Essentially, all of this kind of complicated way to describe the obvious. We're working with speed and velocity here. Physics really likes velocity. Velocity, we're going to talk about, is movement in a single direction. Speed is just what's your total distance traveled divided by the total time it took. So the rate of change, though, rate of change of anything is just whatever value you're looking at divided by time. So in this case, the velocity that I had as I walked away from the wall, we said our change in distance was 20 meters. And our change in time, we said, it took me 15 seconds because I was moseying along. Okay. Keep your units here. Chemistry, I always highly suggested leaving units there. Unit analysis was really important for chemistry. Unit analysis is mandatory and necessary for physics, okay? Just kind of go into the difference between those. So now I have 20 meters divided by 15 seconds. If I go ahead and bring up a calculator here. So I have 20 divided by 15. That looks like it's going to be 1.3, maybe even 1. Hey, look, news. All right. We're going to go into significant figures later on. I'm going to say for this one, though, let's just go with 1.3 meters per second. That unit's going to stay there. So that was my speed away from the wall. What if I started, so let's say that we have kind of the same scenario here. We have the wall there. We have 5 meters there. That's 25 meters away from the wall. Okay. And just to signify that that is in fact me. Okay, I'm awesome. Let's say this time I'm starting 25 meters away from the wall. We're going to say that I'm going to speed up a bit. It's going to take me 10 seconds to get back to where I was when I was 5 meters away from the wall. All right, so how does this look this time? Okay, so things we need to figure out. Ignore that for now. We need to look at our initial value, our initial position, our final position, and our change in position. Time we'll bring back up. So in this case, our starting initial position was 25 meters away from the wall. Our final position was 5 meters away. So in this case, change in position is still final minus initial. This time it's 5 minus 25. Our change in position is negative 20 meters. Time, this time is 10 seconds. So in this case, if I wanted to find, I'll just go ahead and put a V there. I'm going to put a little arrow up above the V that indicates direction's important. And we're going to go into that just a little bit here. So in this case, so V is equal to change in X over time. In this case, we have negative 20 meters over 10 seconds. In this case, we should get a velocity of negative 2 meters per second. Next kind of important rule for physics. So we have a positive value for velocity and a negative value for velocity. If you look at your speedometer in your car, there's no negative miles per hour on there. That's because for speed, direction doesn't matter. Your car has not designated which direction's positive, which one's negative. Even if you throw your car in reverse and back up, your miles per hour is still going to read positive. In this case, me walking away from the wall and me walking towards the wall, I kind of inferred or implied my positive and negative values. Positive is kind of in the direction to the right. Its position away from the wall is positive. Movement or direction towards the wall, position towards the wall, is negative. Probably put a wall here, or 0 would have worked. Okay, So in this case, we just said positive was to the right, negative was to the left, with the wall being our furthest left kind of boundary. You can set up your positive and negatives, any way you want. For the most part, though, we're going to label it. Just how I'm sure you did in geometry when we start looking at things in 2 dimensions. Here you have an x value and a y value. We would need to indicate, positive is that way and that way, negative is that way and that way. All right, so that's velocity in 1 dimension. We're going to talk about Pythagoras and vectors and scalar values next time. But for now, I think that's a pretty good start. We've got some pretty basic practice problems for you. With that, have fun.